Hi everybody and welcome back to Chee-Tash. My name is Chris and today we're going to be talking about chapter 14 from the book Clean Code by Robert C. Martin. Chapter 14 was a very interesting chapter, and if you guys can't tell already, I don't have a PowerPoint presentation going right now because chapter 14, which is titled Successive Refinement, is a chapter in which the author goes through and shows you an example of a computer program that he has written and then goes through and cleans it up using the principles found in earlier parts of the book, principles that we've talked about in all the previous videos, which you can check out on the YouTube channel in the Clean Code playlist. And it's not a chapter in which anything really new is displayed or illustrated. It's really just a working code example of how to refactor, refine, and use the clean code principles found in this book. Now, if you guys didn't notice, I sound a little bit different too. And earlier, some people might have caught that I had uploaded a video for this chapter, and I did it on a new computer. And I had the microphone hooked up, recorded it, sounded great. I thought I did fine, but the audio of the video sounded staticky and scratchy. So I was super disappointed because I had to take down that video. So I had to re-record it. I'm using just the microphone from the MacBook Pro, which I know is not great. I probably sound like I'm in a huge cavernous cave right now, and I don't have my nice and beautiful shiny Audio-Technica mic, which makes me sound so great. But I'm going to re-record this video. And so I do apologize. A lot of the stuff in my coding example is already completed, and it's probably not going to look or feel the best because earlier in that previous video, we were actually coding and going through a previous coding example. But, I thought, what, let's just do this anyway. And we can at least talk about some of the principles in this coding example that I had. I'll do the best I can, and then possibly this might leave it open to do a part 2 of this, which I was planning on doing anyway, because some of the stuff, we didn't get to everything. So without further ado, sorry, I know that was a little bit longer of an intro, but thank you guys for your patience. And again, sorry that I had to re-record this and it might not sound as great as the original video as far as the content-wise, but at least you'll be able to hear me better on this microphone. So without further ado, I created this example. Don't worry about anything outside of this chapter 14 store package. And I created an example of a program that shows a store being created and then adding products to the store and then also adding employees to the store. So you guys can see this here. If I get rid of this maybe, and I blew up the font here, but let me actually stretch it out so that you can see it all on one screen, right? So we have a store, right? And then we can add stuff to the store, like we added my apples and my orange. And this builds a product list. And before, when we did this, I think, looked specifically at the store class first. And right away, we kind of did some refactoring with some of these instance variable names. If you guys remember, we had a chapter where we did talk about proper naming and how sometimes it might be redundant, as you can see here on like lines 12 through 14, or excuse me, 13 and 14, how sometimes it can be redundant to name something as a list when the instance variable, it's of a type of a list of something. So this was one thing we refactored specifically in regards to these employees. So instead of saying we had an full-time employees list, part-time employees list, we just cut it out and said full-time employees, part-time employees. In fact, we even had these at one point just say employees and then second employee list. On top of the fact that the list is redundant, to call this employees and to call this second list of employees is not good naming either, because it doesn't really signify what they are. And you kind of want something a little more specific than just saying, okay, all of these are employees, which they are. And that was something that I was going to get to kind of a little bit later, possibly in part 2, is that I want to really distinguish that this is a full-time employees, list of full-time employees, and a list of part-time employees. So that's kind of the naming convention we went here. And here, we can kind of do the same thing. And I had that comment here. Might be able to just name this pairs. So that was one thing. We did also talk about comments, because in another class, let me see if I can find it. Yes. Okay, in another class, I had some comments here in the Apple class, which is an extension of item, because our store is going to have items. We had a comment here, and I commented this out, don't worry about that, but we commented that out because we weren't really using it yet. But we had a comment here to kind of give the formula for how we're going to calculate circumference. Let me just tell you guys, lines 28 and 29 probably aren't needed, because just by looking at the code, you can look and see what the formula is. We're going 2 times pi times r is how you find the radius, or excuse me, the circumference of a circle, the perimeter of the circle. Circumference is the word for it. So this code right here is not really needed. On top of that, I had another class, yes, Fuji apples, which is of a type apple. And I had this comment up here that gives like a little bit of background on what really Fuji apples are. Again, something like this, we've talked about comments before earlier on the book. Comments like this, specifically for programming purposes, probably aren't needed. Better served in, a tour guide brochure than in your code, because how is this really going to help you code? It's probably not. So it's just adding unnecessary lines. We could probably delete that. And this Fuji apple example, I didn't really get to it in the original recording of this video. But anyways, I think it's just a good idea to get rid of those comments. Let's go back to the store really quick, because you'll notice here I made these private variables. This was something in the original iteration. I had these all public. Now, if you guys remember, we had a chapter where we talked about data and data structures and objects, and the main difference, or like our goals when we use data structures and objects. One of the main points from that chapter was the fact that objects should not show the inner workings of themselves, but data structures can. So if you do want to show specific things of an object, you use functions to show just specific data, but you don't want to show all the data. So this is where I originally changed the instance variables of store. They were public, and I changed them to private. So now you can't really have access to all the information of the store. On top of that, I do have getters and setters here. Now the getters are going to be essentially kind of doing the same thing, so it would be smart for me to probably get rid of all these getters as well, most of them. And maybe this is where it's going to be kind of up to you, or kind of up to how you want to structure this and what information you want available to the client. I had an example here, which was this. Let me actually see, can I go back? Oh, nice, I can go back. So this was the original iteration, and actually I can go back maybe a little more. If I come here, I come there. Let me go all the way back. Yes, okay. I had a method here that was called get Apple products for store. Let me go to my main method. So originally in this main method, we had apples, we had oranges, right? And they were all their own thing. What I did was I extrapolated this out into a new class called item, which is going to contain a price. Now, in my store now, instead of having lists of all these different items, because think about it, your store could potentially have so many different products in there that it fills up. It's got instance variables on top of instance variables, 200 instance variables, just of all the different lists of products, right? Or you could have one list, cohesive list of item, and that no matter what the product is, it's an extension of item. It's a subclass of item. So what I ended up doing was refactoring this a little bit, and we used the Apple example here of having Apple extend item. So now every time you create a new Apple object, it's got this price. It's of a type Apple, but Apple is a subclass of item. That's its superclass here. That's why we're able to set the price. We're using the super class constructor here to set the price, which is item. And we can get an Apple object that's got the item, the circumference, diameter. I was kind of going to use this later. Didn't really get around to it in the original recording of the video, etc. But now what this allows us to do is instead of setting, a list of oranges, a list of apples, we just set a list of items. And in that list of items, we can have apples and we can have oranges. So it kind of cuts down a little bit on just the amount of, I guess first off, the amount of instance variables, but also the amount of code in your main method when you're just creating and setting all of these bunch of lists, and you just have one method here just to set your products. And in that set of products, you have apples, you have oranges, etc. Let's go back to store. And this is where this method came in. Because I originally was thinking, okay, I don't want to show all the data from my store. And remind me of this, we got to get back to this naming convention here, because I do want to talk about some of the names that I have here as well. But anyway, store number one, we've got the products for it, right? I don't want to show all the products in the store. I don't want to show all the inner workings. I don't want to show the address to the client. I don't want to show the store number. That's not going to mean anything. I don't want to show the employees, but maybe what I want to do is I want to get just the apples from the store. Get the Apple products for the store, right? So I created this method to say, okay, instead of calling, your list of items and then having to, do your own work to loop through it, okay, let's have a method that just does it all for us. So that's where the birth of this method here, get Apple products for store. No, this does not mean cell phones and MacBooks. This means the apples that you eat for this store. So this is what we did. We passed in this list of items. We created a new array list, and we looped through the list to check if the items in the list are of an instance of Apple. And if they were, then we add them to this list and then we return the list. Great. One thing that's wrong with this. First of all, we had to name this differently, because I think the original name for this was get products, right? And I think that's what I was reiterating here, I believe, with this method, but we renamed it. And I think this is a getter anyway. Let's not, let's kind of ignore that for a second. But if my method here was called get products for store, that's probably not the greatest method. What do I really want to do with this? I want to filter out the apples. Let's name this a little better. So we called it get Apple products for store. Okay. This is taking in a list of products. Now this is problematic. Earlier on in clean code, we talked about how functions should try not to have arguments. And I know that kind of sounded crazy to me at the time when we made the video. I was kind of thinking, well, I make methods with all like 3, 4, 5 arguments at a time. But what he says, and we'd have to go back and look at it, but he basically says the more arguments you have, the not as great as it's going to be. Maybe the harder it is to test specifically. You have to think of more test case scenarios for each of those arguments. It's better to have only the amount of arguments that you need, and the best amount of arguments, I think he said, was just none for your methods. Okay, that's one thing. But also you're passing in this list of products. It might not be guaranteed that this list of products is the same list of products up here. So I changed this method around a little bit, and I wonder, what is this, command shift Z. So I wonder if I can go back. Yes, okay. So I can come back here, and I can go back forward. And I want you guys to see what I did here. And you can kind of see it here in this for each loop, where instead of looping through a list that I'm passing in, I'm now looping through this products list, array list. Where is this products list? Where is this product coming from? It's coming from the instance variable, so that we know that we want to get the apples for this specific store that we made, for store number 1. So we only loop through the products that are set for that particular store. And this is one way to do it, but I did find maybe a shorter way, and we kind of refactored this method a little bit to try to keep it short, to try to keep it very clean, and we kept it pretty much to one line here. And I think this is going to add a collectors, yep. And I think we got rid of this because we don't really need this. So we just had this, which is nice and succinct on pretty much one line. Pretty much one line. So this is, if you guys are familiar with Java streams, I didn't use these for the longest time, but just as of recently, I've been using these a lot. So you stream in, then you filter it, kind of like a JavaScript array method. Item is the predicate. What are we going to do to the item? Well, for each item in the list, we want to check if it's an instance of Apple. If this Boolean turns out to be true, then we're going to collect it into another list, and we're going to return that list, so that then we can call this over here. And now we're getting the list of items, which are apples, from the list of items, right? I know this is saying here that this is a list of items, but remember that apples are an item. It is an item. So we have to be very careful with our naming convention here. Like if we name this list, probably not a great idea, right? We got to be pretty specific here that we just want the apples from the list of items. And that's what this method is going to do for us here. Being nitpicky, yeah, maybe you can do something like this and have it be all on one line. But I think stuff like that is good for the getters and setters. And I had an example, I think, where I was doing this. If I can find it for you guys. It was with the getters and setters. Maybe I didn't. Okay, that's fine. I think for getters and setters, like here, I think it's probably okay you do something like this because it's something really simple. But even for this, I like the spacing of having the brackets on each line here, and then having your code, even if it's one line, just in between your brackets, which are on separate lines. So this takes up 3 lines instead of the 1. I think it just looks a little bit cleaner. We did have an example in the original recording. I think it was with Apple here, where the spacing here was a little messed up. So I think I had something like, this, I think. And you kind of look at this constructor and you think, oh, this has just got, it's setting 2 instance variables, and then this gets kind of confusing here because you maybe might not notice it. So for constructors, it's maybe best to have your instantiation, each one on each separate line. So we kind of talked about that earlier in the original recording as well. And then coming back to this naming convention here, yeah, I think originally I had this as like store1, right? And maybe again, this probably wasn't like the best naming convention here, and I thought to, maybe make it a little bit more specific here with the store number 1, or I guess, yeah, store 1 would work, or store number, and you actually have maybe the number 1 here to signify that that's the number, because I mean, how's it going to look if you have store number 123? Are you actually going to type 120? No, that would be kind of ridiculous. It might be easier just to do something like this. Store number 123, and then people get, the gist of what you're trying to do. Let me go back. Let me correct this. Okay, store number 1. Cool. What else? What else did we talk about? What else did we talk about in that original recording with the employees? No, we didn't touch on the employees yet. We definitely touched on this list of items. If I go back to the Apple class, yeah, we have this circumference, and I guess this was one thing that we could talk about here as well. Is maybe here I'm doing the calculation for circumference right here in the constructor, even though I'm passing it in. So this would have to kind of be refactored, and I'm trying to think if maybe circumference isn't an instance variable, and especially too because this is public, so we can automatically, let's change these to private, right? So I can make this private, I can make this private, and maybe we don't even have a circumference instance variable. I know at least we could get rid of this. At least we could get rid of this. We don't have to have the circumference because it's being done here. We know circumference is pi times diameter, or 2 pi r, right? But maybe we don't even need the instance variable here. That's a little bit too much. Maybe that might cause us to, maybe some data, what's the word, like data compromisation, and we don't want to show the circumference of the apple. But if you want to know, we can calculate it for you. So we can call on this function to do it, but we're not going to show it or let the client have like as easy of access to it. I know that's showing red too. Let me just get rid of this toString method. So we can calculate the circumference here. We first take the radius, which you don't have to do. So we take radius equals diameter divided by 2, and it's 2 pi r is the calculation for circumference. Okay, cool. If you wanted to get super crazy, you could maybe even divert this into its own separate function. So I could have, let's say maybe down here where I have a private get calculate radius function, right? Calculate radius function, that's going to take in a diameter. Let's not take in the diameter, so we're kind of going to use a similar example that we did in the store for getting the Apple products for the store. We don't need to pass in the list, or excuse me, not the list, but the diameter into this method. Let's just keep it as is, and let's just return diameter divided by 2. Diameter divided by 2. Oh, excuse me. Private, and what is diameter? Diameter is an int, so let's just return an int here. So this is good. We're not passing in a variable here. We just take the diameter that's been instantiated for the particular apple that we're working on. And we can kind of extrapolate this out. So we don't do the calculation here. And we just say calculate radius. We get the radius, right? And then we do the calculation like that. So this is kind of abstracting out function, and this might be a little bit too nitpicky, a little bit like doing maybe a little bit too much. But this method is supposed to calculate the circumference. It was doing the calculation of the radius as well. Again, maybe us being a little bit too nitpicky, maybe a little bit too clean that it's not needed, but just as like a way to show you guys that, hey, remember when we talked about functions really should only have one job. Classes should really only have one reason to change. So we can abstract out the functionality of calculating the radius into its own function and then call that function here and then leave this function's calculate circumference. Hey, it's going to do exactly that. It's not going to do anything with the radius. That's going to be that method's job. And then we calculate the circumference using the radius calculated from this method. So that's another way to refactor it. That's another way. And then again with this, maybe we don't even have, like this argument here, we could even clean this up because that diameter is not even used. And we can just get rid of that. So that when in my store, you know, I don't know, let's say if we did want to know what the radius was, we can, or excuse me, what the circumference was, we can easily do that. We can assign this to my apples circumference equals this. Oh, and it's a double. That's my fault. There we go. If we wanted to, we could even we could print this out. My apple circumference. Oh, I'm sorry. I thought that was a print statement. I'm sorry, guys. But yeah, let's say if I come down here, print this out. Let's run this. Let's see what we get. Oh, I didn't. How come that didn't print? Oh, that's hilarious. Okay, there we go. I didn't actually print it. All right, sorry guys. There we go. So 0.0. Probably having to do with some, oh gosh, what's the word? Some, not marshalling, but casting. Yeah, so circumference 5, diameter 1. Yeah, probably calculate circumference. So the diameter is 1, calculate radius 1 divided by 2 is 0.5. Okay, this is returning an int. What if I did like a double here? Calculate radius, int radius. If I say this is a double, this might get us something. Still not doing that. Let me try to cast this again. Sorry, guys. If I try to cast this to a double. There, okay, yeah, I think that's, yeah. I think that's better. Yeah, yes, okay, that's right. So it was probably, tricky things happen when you try to cast. It's either like you cast up or you cast down. That's not the exact right term, but to go from an int to a double is like an increase in the amount of, like the range of numbers that are possible, right? So there's a difference between if you go from an int to a double and a double to an int. This diameter was an int. We want to make it into a double. So it's better to cast it, else what is 1 divided by 2, right? It's 0.5. It's 0.5. But when you cast it to a double, I think the 0.5 gets lost, so it rounds it to like a 0 or something like that. So just to ensure, we got to cast it here. But anyway, that's correct. So with a diameter of 1, if I go back to my store, with the diameter of 1, 1 divided by 2 is 0.5, 2 pi r, so now 2 times 0.5 is 1, 1 times pi is 3.14, so that makes sense that we are getting 3.14. Another thing that I just see that we can also refactor my apples, and this is just a single apple, probably would be better to just say my apple, or specifically call this I don't know, Apple product 1, or here's where maybe you would say something specific like a specific company's Apple. I'm trying to think of like what's a popular Apple company. Not like Chiquita. That's for bananas, but oh gosh, I don't know. Musselman's. Musselman's Apple. And this might be a little bit better of a naming convention here, and then we would change, we would change these as well. So I can do that really quick here. Boom, and then boom. Because it's not my Apple, it's like an Apple for the store. Now, maybe later on we choose to add a shopping cart. Yeah, maybe it would make sense to name, it's my Apple that I'm buying. But in this case, we're kind of designating it more so as like a product. So that's kind of all I wanted to go over today. Just kind of refactoring the code, changing up the way we name things, changing how we access certain variables, refactoring some functions here with this getting Apple products for the store, only exposing the data that we want to, kind of getting a little taste of that. With the circumference, really abstracting out the functionality and making a separate method do the calculation of the radius, and when we want to calculate circumference, that's all that is going to do for us. So that's all I wanted to go over, guys. Thank you very much for listening. I really hope the audio quality is okay for you. I know those of you who caught the original recording, again, my apologies that I recorded like that. Very unhappy that had to happen, because I thought it was a really cool recording and a really good first episode diving into doing a live coding example like this. So hopefully you guys like this one. Hopefully it turns out good. Tune in. Full interview with Julie Hammerly is out this week. So check that out on Google, Apple, Spotify, Amazon, etc. Thank you guys so much for listening. We'll be back. Maybe we might do a part 2 to this video, or we might skip ahead to chapter 15. But thank you guys so much for listening. My name is Chris. This has been Chee-Tash. Take care, everybody.